Hello, this is Tony Verbsky here, the lecture over section 2B, extending unit analysis. First, I'd like to start with a problem of my own. So if I have 55 miles per hour and I'd like to convert it to feet per second, here's what I learned when I was in high school. 55 miles per hour, what we're going to do is multiply by a couple of funny looking ones. Now, I'd like to get feet, and I'd like to get rid of miles. And in 1 mile, there's 5280 feet. And since you live in Denver, that one's pretty easy. Now, I'd like to get rid of hours, and I'd like seconds downstairs. Now, in 1 hour, I know there's 60 minutes and there's 60 seconds in each minute, therefore 3,600 seconds. And the hours cancel, and you're left with feet per second. Then you multiply straight across, you multiply straight across, and we get 55 times 5280 divided by 3,600 feet per second. On 55 times 5280 divided by 3,600. 80.6 repeating. 80.6666. This 6 is a 5 and above, therefore that becomes 7 if we're rounding to the nearest thousandth. Oops, most important, feet per second. Now the book has their way of doing problems. They're usually the same as mine, but sometimes I think I might explain it better than the book, but that doesn't mean I do explain it better than the book. Anyway, we're going to start by going into the textbook, which is, if you go chapter contents and MML, and I picked section 2B, and look at these. There's a video presentation, meaning you don't need me. There's an e-text, that's where I'm going, and there's even a study plan, but that's going to add a ton of extra work, so you may not want to do that. So I'm going to go into the e-text, and seriously, this is a really good book. I'd read it and work along in it because traditionally it has interactive examples. Taking a little while to load here. That's the drawback. Let me get into page 89 and look at all those conversions. When I was a kid, and I can't write on top of this, but I used to make firewood, and I make cords of firewood all the time. I'd be getting bushel baskets of oats and putting them in gunny sacks, and it'd be like 4 bushel filled up our big gunny sacks, but you see 1 bushel is 4 packs, and a pack is 8 dry cords. I used to know all these things, but tell you what, I didn't know what a dram or a scruple was, or a troy pound versus troy ounces. But these are going to be the things that help me convert. And this one here is 1 mile is 5,280 feet. That's the one they just used. And I also use hours and seconds. So if you're struggling, maybe print this page off. I don't know if it's needed for the homework or not because I haven't done it yet myself. Also, while I'm here, page 91 has a review of the metric system on it, and we're gonna get into that here in just a little bit. So I'm gonna start with example 2 in the book, And I don't work all the examples, but you can see that in the book it says now try, these exercises. Now try um, exercises 21 through 24. So this example goes with that right there. Now I haven't really got seriously in, oh, I missed it. But right here, price comparison to lower, it goes right through the problem, and there's a nice video here.
Let's look at the example using the U.S. customary system for change.
So, I want to do my part. I want to feel what you're feeling. So, um, you could bypass me. You really could. But I'm, I don't know how to explain it. I'm a real guy. I make real mistakes. I do understand what it's like to struggle in math. Why? Because every mathematician on the face of the earth has been pummeled by math their entire life. So, it's just a tough thing to work with all the time. Now, granted, our problems may be different, or we may make the same mistakes, but you're going to see me actually most likely make some mistakes, and hopefully you find, you know, my presentation helpful. I'm just pretending you're here in class, just as if it were a regular on-campus class. That's all we're doing here. All right, moving on. I'm going to work example 2 in the book, exactly page 91. I don't want to be doing a whole bunch of extra stuff. Now, what we have here is you're planning to make pesto. I like pesto sometimes. And you need to buy basil at a grocery store. You can buy small containers of basil, priced at $2.99 for 2/3 of an ounce. So $2.99 for 2/3 of a ounce and CE. I hate it written like that. Here's what I like: $2.99 per 2/3 ounce. That's what I like. That's how it just makes sense. Dollars per. So the per thing goes on the bottom. Now they want me to convert it to dollars per pound. So way over here we want, oh, I should have left myself a little more room. We want blank dollars per pound. Now we already got dollars, so we want to get rid of ounces. And we want pounds. Well, in 1 pound, there's 16 ounces. So you got to go this times this divided by 2/3, because the ounces cancel and we're left with dollars per pound. So let me do this on the calculator. $2.99. If I turn it on, times 16, enter. Now this is going to be careful. We can play it safe. Divided by point, 2/3 is a whole bunch of sixes, and we get 71.760. So we look, if we're going to the nearest, oh, this would be dollars per pound, so we're forced to just go right there, $71.76 per pound. But then you write it out as dollars per pound. Matched it. I did good. Next problem. Well, we gotta convert. Let's work on the metric. This is verb examples. Verb, that's me. If we got 23 centimeters and we want to go to meters. Now, centimeters is, they say it's, you know, 10 to the minus 2. Now, what does that mean? Well, we want to go to the meters, so what we're saying is, well, here's what I like. This is smaller, and this is bigger, because the meter is bigger. So if you go from smaller to bigger, you have to move it over 2.23 of a meter. They mention that centi means 10 to the minus 2. Now, 10 to the minus 2 means that you move it 2 to the left. So another explanation would be, well, if you want to go from centimeters to meters, you multiply it by 10 to the minus 2. Well, that is really 10 to the negative 2 means divide by 10 squared. That's really what it means. And that's 23 divided by 100. And now maybe you know to move it over by 2 and get that. Let's try another. 580 nanometers, and we want to go to micrometers. Well, that's a 10 to the negative 9er, and this is a 10 to the negative 6er from the table. Now, I know that nanos are smaller than micros by 10.3, because the difference in 6 and 9 is 3. There's 3 tenths different. So I know that there's going to be a shift of 3 one way or another. Now, this is the small and this is the big. So we got to make this smaller to go over here. That's one way to explain it. I actually like that way the best, personally. It just seems to work. I teach electronics also, and we do the conversions, and my students just reason it out. They go, there's 3 different, so it's either you're going to be shifting right 3 or shifting left 3, and when you go from smaller to bigger, you got to make this smaller, or else it won't be in balance. All right, with that said, there's a big review. So there's a big review on page 92. Meaning, if you're terrible at this, you work the big review. No, you need to, I would work it. It looks really good, actually. It helps you with your tens, which is a good thing. Multiplying by 10, dividing by 10, helps you with your exponents and all that good stuff. Okay. The book, I did not like 3B. So 3B, they go, how many nanoseconds in 1 microsecond? Well, the book says nano is 10 to the minus 9, and the book says micro is 10 to the minus 6. Now, nano is ns seconds, and micro is mus. Now, in 1 microsecond, we need blank nanoseconds. Now, we know that 10 to the minus 6 and 10 to the minus 9, this means you're dividing by 10 9 times, this means you're dividing by 10 6 times. Clearly, nanos are smaller than micros. So there's going to be a lot more of these, and there's a 10 to the 3 difference, which means you're going to either shift left 3 or shift right 3, and there's going to be a lot more of these than these. So here's the 1, and you go 1 2 3, therefore 1,000 nanoseconds. Versus the book's explanation, I don't know what they're doing there. It's a poor job. There's another explanation that's better that I kind of like. 1 microsecond implies it's 1 times 10 to the negative 6th seconds by definition. Micro, and it gets rid of the prefix out front, and that 10 to the negative 6 goes whatever this number is times 10 to the negative 6. Now you know 10 to the minus 6th, you got to move it. If you're going to make this bigger, you got to make this number smaller. So if you're going to get rid of it, you got to move that over 6 places. So that'd be 1 2 3 4 5 zeros and a 1 seconds. Now, if you want to go to nanoseconds, you know this is seconds, and nano, you got a 10 to the minus 9, which means you know you're going to shift it 9 places. But this is way bigger than this, so there's going to be a lot more of these. So 6, 7, 8, 9. I think that's still better than the book. All right. So there's more conversions on page 93. Sorry, I don't know where my e-text went. Oh, get rid of this. Page 93. Oh, yeah, while we're there, there's that power of a 10 brief review. Looks like it would help some people, I'm sure. We just worked that problem there, as you can see, nothing fancy. But 1 inch, 2.54 centimeters, always knew that. 1 centimeter, that many inches, had no clue, etc. So if somebody's asking me something with relation to these, I'd be set. I think in the problems I want to use, 1 mile is 1.6093 kilometers. So next problem. So example 4 is 26.2 miles, and we just simply want to convert it to kilometers. So here's the deal. Mr. Jensen, that was my teacher, taught me this game, miles, and we want kilometers, so kilometers. And in 1 mile, there's 1.6093 kilometers. I looked it up in the table. The miles cancel, therefore I'm done. So you just go 26.2, 1.6093, and I get 42.1636. You want to go 3, look here, 5 and over, bring it up, 42.164. If you're rounded to nearest thousand. If you have a square that's 1 mile by 1 mile. The area is length times width, or the side squared. So the area is 1 times 1 is 1. Mile times mile is mile squared, which is 1 mile times mile. Now, I want to go to kilometers and kilometers and miles and miles. And there's 1.6093. I did not know that till this evening. My. Done. Answer 1.6093 squared, or times 2, times itself. .589. So 2.58984. Let's say we're going 4 decimals deep. You look at the 4, you leave the 8, because it's not a 5. That'd be to the nearest 10,000. There, you go through about 2 pages of Fahrenheit, Celsius, Kelvin temperature stuff from maybe a science class. Some of you may be in them. So example 6, I don't even know if I'm working it. No, I'm not. But here's all these equations from your past life, maybe your current life. So I love it when people give me equations, because I just plug numbers in and score points. So you just got to know which one to plug it into, right? Kelvin equals Celsius plus this absolute 0 number, if I'm not mistaken, 1.5, and Celsius, Kelvin minus 273.15. If I remember right, it's like absolute 0 is the coldest possible temperature, usually of negative 273.15 degrees Celsius, so they called that 0 Kelvin, and then we had Kelvin temperatures. All right, so we can do example 7. I don't know if I need to. Sorry about the undo there. But basically, if you have 98.6 temperature of the human body, average temperature of the human body, I helped lower it. I think my average temperature over the years is 97.7 or something weird like that. The only reason I remember that is when I gave plasma in college. Literally made $40 a week for 5 years giving plasma. My temperature was always low. And if I rode my bike in the wintertime, they used to make me warm up for about an hour before I could donate plasma. Anyway, maybe that's why you listen to these lectures, to hear these stories. We want to go here because they want me to convert to Celsius, and that's all there is to it. So 98.6, they want me to go to blank Celsius minus 32 for 1.8. You can do it like this: 98.6 minus 32, enter, divided by 1.8. You can go parenthesis left, 98.6 minus 32 parenthesis right, divided by 1.8. 37 degrees Celsius. All right, next topic. I teach electronics. This is my 2nd year. I teach for Spartan College of Aeronautics and Technology at my high school, Highlands Ranch High School. By the way, I've been at Metro State since 1994. Been adjunct, been on campus almost the complete time, for the whole time. I taught trigonometry online with real good success. And this is my second time teaching online. Um, of course, next time I teach it, I'll have all my resources built, and probably just have to make some adjustments. But this time, I need to be right there with you, digging in the trenches. So, um, anyway, I teach electronics, so they have this. They're talking about energy, and energy is said to be measured in joules. I'm like, okay. And it's not the thing you smoke, by the way. And the symbol is J. Now, power is the rate of energy. And 1 watt of power is equal to 1 joule per second. Now, you know how it is when you're riding those exercise bikes or your Apple Watch. By the way, I have one. And they say 500 cals per hour. That's what you're running. Now, just so happens if you look up in the table, 1 calorie, 1 calorie is 4184 joules. So that's my funny looking one, because what I want to do is divide by calories to get joules, and 1 calorie you get 4184. But it's defined in seconds, and I want seconds on the bottom. I want to get rid of hours on the bottom, so you put hours on the top. In 1 hour, there's 3,600 seconds. Now the cals cancel, the hours cancel, and I get 500 times 4184 divided by 3600, 581.11, 81.1, repeating, joules per sec. Now, that's the rate of energy. If you have a 100-watt light bulb, oh, by the way, joules per second is watts. If you have one 100-watt light bulb, you can basically light it with the power generated by you riding this exercise machine, or basically you can light not one light bulb, but really you can light 5 100-watt light bulbs, almost 6. So you could throw in a 75-watt bulb and literally light 5 100s and 175, no problem, full brightness, just by pedaling, let's say, a bike. That will help me, because I hate the calorie thing. I don't understand it. Now the watt thing, that does help too, because sometimes those machines tell me watts. Now I can think about light bulbs. How many light bulbs am I burning? That might help me. A huge one is a kilowatt, and the stupid book goes -hour. Now, I'm going to abbreviate it. 1 kW, where the W is going to stand for watts, I guess. I probably shouldn't abbreviate it. It's really times hours. It's not -hours, it's kilowatt hours. It's weird. It's like a units times the units. So kilowatt hours. is a unit of energy. Is a unit of energy. But I thought energy was joules. So is this joules? I don't know. It bothers me some. I'm going to have to think about it. But they say 1 kilowatt hour is equivalent to 3.6 million joules. I was right. Kilowatt hour is joules. I don't like the 3.6 million. I like there, 3.6 million joules. And I could have used J. Now, if the utility company wants to charge you 15 cents or dollars per kilowatt hour, that's the charge. And how much does it cost to keep a 100-watt light bulb on for a week? So let me see what I'm going to do. So let's just start this. 100 watts light bulb for 1 week. Well, what we'd like to do is multiply by 1 kilowatt and over watts. So let's convert watts to kilowatts, and then 1 kilowatt, there's 1,000 watts. Phase 1. But we've got to mix some time in it. So we got to get some time in it. So you just throw in 1 week. Ooh. Right, 1 week. Because what we want to do is get this in the right format. Now, 1 week is 7 days and 1 week. Watt weeks. Yeah, that's kind of funny. I think we really should be given 100 watt weeks. It just seems really weird, but they're the ones that make up kilowatt hour. So I think I just seen the problem in a whole new light. Sorry to just think freely there. You want to get rid of, so the weeks are gone. You want to get rid of days. So you put hours, and 1 day there's 24 hours. Days are gone. Watts are gone. After everything's said and done, they sneaked in kilowatt hours. So I got a better explanation already, but let's get this down. So you go 100 times 7 times 24 divided by 1,000, and you get 16.8 kilowatt hours. Now, if you know the kilowatt hours, 16.8 kilowatt hours times 0.15 dollars per kilowatt hour. The kilowatts cancel, the hours cancel, just leaving me with dollars. 16.8 times 15 cents is $2.52. 252, put the dollars back out front like a regular person, and then you're done. This is kind of dumb, but my other explanation is you had 100 watts over 1 week. So technically, we started with 100 watt weeks. And then we had to change it to kilowatt hours. So if you get rid of the watts and get in your kilowatts, and you get rid of your weeks, and then you throw in the days, in 1 week there's 7 days, but then you get rid of the days and you bring back the weeks. Oops, I already got rid of weeks. So back up the truck. Hours. We want hours. Got to get rid of days. And one day there's 24 hours. So the days cancel. The weeks cancel. The watts cancel, leaving you with kilowatt hours. I don't know if that's better or not. Hopefully this helps. Remember, my job is not to do every example. As I showed you earlier, the book has a lot of really good videos. It can help you walk you through the example. Should be good. Ooh, ear infection. We should probably work the ear infection problem. This is always a problem because you got kids, and then in medicine stuff is never right. A child weighing 15 kilograms, so you got this kid, little 15 kilogram, has bacterial ear infection. Well, my kid didn't really have it, but my dog always had it. His name is Brett Favre, a Wheaton Terrier. He's a good dog. A physician orders treatment with an antibiotic amoxicillin with dosage 30 milligrams per kilogram. So you got this amoxicillin, so it's in a bottle. It's like pink stuff, isn't it? And it pours out, and you need 30 milligram of the liquid per kilogram. But my child weighs 15 kilograms, so I need 450, because that's 300, and then half of it, 150 more milligrams. Oops. Should read the rest of the problem. Divided into a dose given every 12 hours, so divided by 2, because I did it over a full day, and I get 225 milligrams per dose. Oh, how do you spell dose? There we go. Too bad medicine is really, most of the syringes or the things that you dump medicine are cubic centimeters. So not that we care, but 1 centimeter cubed, I believe, is equivalent. I always look on the side of a bottle. So many milliliters. At 1 ml. There we go. Milliliter. But this is in grams. So I think it's similar to 1 milligram if we're talking about water. That would be a lot of cubic centimeters per dose. I'll have to rethink that. But I got the problem right. My daughter's 21. Probably forgot how to do this. All this fancy medicine stuff. And good enough for what we're doing. It looks like I made it, guys. And I don't know where I'm sitting, but hopefully it's less than 30 minutes. Ouch, 39 minutes. Man, I'm sure had fun during that. So remember, watch this video, read the textbook, work the animations, watch more videos, then work section 2B. Trust me, it'll go way better. You'll learn a lot more. The class will be less painful to just pony up like we did at the beginning. Why do you think I threw you out to the wolves? You're struggling on section 4A or wherever sections you guys are struggling on. You got a bunch of those problems wrong. By the way, hey, work similar problem. You can get 100% on everything. You can go back and get 100% on everything. Those first three aren't due till September 3rd, as it says in my math lab. Anyway, got to put an end to this and get it posted. Good night or good morning, whatever time it is for you.